Hello viewers, in this video lecture, today we are going to talk about the module Fundamentals of Energy Science, in which I am going to deliver lecture 3, Alternative Energy Resources. In the previous lecture, we have learnt about Indian and world energy scenario. So viewers, here are the important topics which will be discussed in this video. Solar energy, wind energy, biomass and tidal energy, geothermal energy, fuel cell, hydrogen energy. Now, we will discuss in details. Now, you people might have question in your mind, what is alternative energy sources? So, I am here to answer. Alternative energy refers to the energy sources other than fossil fuels such as coal, petroleum and diesel, and includes all renewable and nuclear energy sources. Although nuclear energy is not as bad for the environment as fossil fuels, it still isn't classified as a renewable energy source because nuclear material cannot be replenished within a human's lifetime. Nuclear energy is produced by using elements like uranium and thorium, which cannot be replenished and have finite amount in existence. Now, what is an advantage to alternative energy technology? The major advantage of alternate energy technology is that it will not run out. Our days using fossil fuels are numbered. So, all the alternative energy sources are beneficial over traditional sources. Another huge advantage is that many of them do not require the same damaging and expensive extraction techniques as much of it is available to use here on the surface. Now, what are the different types of alternate energy? There is a surprising number of the forms of alternative energy, some well known while others are relatively unheard of. Alternative energies are first solar energy. This is probably the most common known source of alternative energy, and for good reasons. Solar energy is completely renewable and the cost expended on installation can be made back through energy bill savings. The only potential setback of the solar panels is that they are prone to deterioration over time and aren't completely weather safe in countries with erect weather conditions. Second is wind energy. This is one of the cleanest and most accessible sources of energy. Wind power is sustainable and doesn't release carbon emission as byproduct. It is also entirely renewable as there will always be wind. Energy sources such as fossil fuels often fluctuate in price. A typical wind farm repays its carbon footprint in around 6 months or even less, which provides decade of zero emission energy that displaces fossil fuel energy. Third form of energy is biomass energy. This type of energy can come in several forms. Biomass energy can include anything from burning wood or burning waste. So many countries do not. With biomass in the form of burning wood, the heat generated is often equivalent to that of central heating system, and the cost involved tend to be lower than a household or a building that uses fossil fuels. It is not, however, a green energy source, even if it is technically renewable. Biofuels. Biofuels are somewhat like biomass, but biofuels uses biological matter like animal and plant to create energy. Biofuel is renewable when plants are used because, of course, plant can always be grown. However, they do not dedicated machinery for extraction, which can indirectly contribute to increased emission even if biofuels themselves don't. In 2020, total biofuel consumption accounted for about 5% of total US transportation sector energy consumption. Fourth is tidal energy. Tidal energy is power produced by the surge of ocean waters during the rise and fall of tides. Tidal energy is a renewable source of energy. Tidal power or tidal energy is harnessed by converting energy from tides into useful forms of power, mainly electricity, using various methods. Although not yet widely used, tidal energy has the potential for future electricity generation. Tides are more predictable than the wind and the sun. This method of energy production is still fairly new and has only produced a small amount of energy so far. So, it will be a long time before we see real results from tidal energy. Geothermal energy. The term geothermal originated from a Greek in which geo means earth and thermal implies heat. Hence, from here we get geothermal energy definition. Thermal energy that derives from the 1800 miles below the crust of the earth contained in the hot rocks, hot water, hot brines or steam. It is the heat deposited in the rock and fluid filling the pores as well as fissures of the earth's crust. Geothermal energy reaches the surface of earth through water or steam. Geothermal energy is obtainable all over the planet. However, the earth takes several years to generate this energy by decaying the minerals and forests. Sixth is fuel cell. A fuel cell is an electrochemical device that converts the chemical energy from a fuel such as hydrogen, natural gas, methanol or others directly into electricity and heat through a process called electrochemical reaction. Fuel cells operate without combustion, making them a clean and efficient energy conversion technology. Now let's discuss about hydrogen gas. This is an important energy carrier and a potential alternative clean energy fuel with a notable stack in the global fuel market. However, today hydrogen gas is largely produced from fossil fuels which pose a threat to the environment. A more sustainable version of this energy source has been described as a biohydrogen, and there are hopes it will be derived from organic biodegradable waste in the future. Now let's discuss few points about solar energy. Solar thermal power plants are electricity generation plants. A typical solar thermal plant captures the infrared radiation that falls on the earth and uses it to heat a thermodynamic fluid in order to drive a heat engine. A solar thermal facility can exploit a small amount of long wavelength visible radiation too, and power generating plants are able to use around 50% of the energy in sunlight that reaches the surface of the earth. Solar thermal power plants are electricity generation plants that utilizes energy from the sun to heat a fluid to a high temperature. This fluid then transfers its heat to water, which then becomes superheated steam. This steam is then used to turn turbines in a power plant. This mechanical energy is converted into electricity by a generator. This type of generation is essentially the same as electricity generation that uses fossil fuels, but instead heat steam using sunlight instead of combustion of fossil fuels. These systems use a solar collector to concentrate the sun's rays in one point to achieve approximately high temperature. Working principle. Now we will take the working principle of reflector. Mirror reflects and concentrates sunlight. Receivers. Receivers collect the solar energy. A heat transfer fluid is heated and circulated in the receiver and used to produce the steam. The steam is converted into mechanical energy in a turbine, which provides a generator to produce electricity. Solar thermal power plants are electricity generation plants. A typical solar thermal plant captures the infrared radiation that falls on the earth and uses it to heat a thermodynamic fluid in order to drive a heat engine. A solar thermal facility is able to exploit a small amount of long wavelength visible radiation too. This type of generation is essentially the same as electricity generation that uses fossil fuels, but instead heat steam using sunlight instead of combustion of fossil fuels. These systems use solar collector to concentrate the sun's rays at one point to achieve approximately high temperature. Now we will discuss about wind energy. Wind is caused by the uneven heating of the atmosphere by the sun's variation in the earth's surface and rotation of the earth. Mountains, bodies of water and vegetation all influences the fluid flow patterns. Wind turbines convert the energy in wind to electricity by rotating propellers like blades around a rotor. The rotor turns the drive shaft, which turns an electric generator. Three factors that affect the amount of energy a turbine can harness from the wind are wind speed, air density and swept area. Now we will discuss a bit about modern turbines. The most common design of the wind turbine is horizontal axis wind turbine, also can be abbreviated as HAWT. That is, the axis of rotation is parallel to the ground. Horizontal axis wind turbine rotors are usually classified according to the rotor orientation, that is upwind or downwind of the tower. Hub design like rigid or teeth ring. Rotor control, pitch versus stall. It can be also classified in number of blades, usually 2 or 3 blades. How they are aligned with the wind, free yaw or active yaw. Now let us discuss about biomass. Biomass is a term for all organic materials that stems from plants including algae, trees and crops. Biomass is produced by green plants converting sunlight into plant material through photosynthesis and includes all land and water based vegetation as well as all organic waste. The biomass resources can be considered as organic matter in which the energy sunlight is stored in chemical bonds. When the bonds between adjacent carbon, hydrogen and oxygen molecules are broken by digestion, combustion or by decomposition, these substances release their stored chemical energy. The conversion of biomass into energy can be achieved in number of ways. To provide a fuel suitable for direct use in spark ignition gas engine, the fuel must be provided in either a gaseous or a liquid form. Production of a gaseous fuel from biomass can be achieved by the application of a number of technologies, each with its specific requirements. Now let us discuss about advantages and disadvantages. Biomass is a plant material derived from the reaction between CO2 in the air and water and sunlight through photosynthesis to produce carbohydrates that form the building blocks of biomass. Typically, photosynthesis converts less than 1% of the available sunlight to stored chemical energy. The solar energy driving photosynthesis is stored in chemical bonds of the structure. Components of biomass. If a biomass is processed efficiently, either chemically or biologically, by extracting the energy stored in the chemical bonds and the subsequent energy product combined with oxygen and carbon is oxidized to produce carbon dioxide and water. The process is cyclic as the CO2 is then available to produce new biomass. Using biomass fermentation, there are several types of processes that can produce an alcohol, that is ethanol, from various plants, especially corn. The two most used processes involve using yeast to ferment the starch in the plant to produce ethanol. One of the newest processes involves using enzymes to break down the cellulose in the plant fiber, allowing more ethanol to be made from each plant because all of the plant tissue is utilized, not just the starch. Burning. We can burn biomass in waste to energy plants to produce steam from making electricity, or we can burn it to provide heat for industries and homes. Let us discuss about bacteria decay. Bacteria feed on dead plants and animals, producing methane. Methane is produced wherever organic material decays. Methane is the main ingredient in the natural gas, the gas solid by natural gas utilities. Many landfills are recovering and using the methane gas produced by the garbage. Conversion. Biomass can be converted into gas or liquid by fuels by using chemicals or heat. In India, cow manure is converted to methane gas to produce electricity. Methane gas can also be converted to methanol, a type of alcohol made for fermenting wood. Methane and methanol each have only one carbon atoms. Biomass and the environment. Environmentally, biomass has some advantages over fossil fuels such as coal and petroleum. Biomass contains little sulfur and nitrogen, so it does not produce pollutants that can cause acid rain. Burning biomass releases carbon dioxide, but growing plants for the use of biomass fuels may also help to keep carbon dioxide level balanced. Plants removal carbon dioxide are greenhouse gases from the atmosphere when they grow. Now we will discuss about tidal energy. Tidal power exploits energy drawn from the movement of ocean tides to produce electricity. There are two scenarios in which tides can be tapped for energy. The first is in changing sea levels. This phenomena is responsible for the advancing and receding tides on the shorelines. With the help of turbines, incoming tides can be manipulated to generate electricity. The second way to exploit tidal energy is by sinking turbines to sea floor where the fast flowing currents turn generator blades much like wind does with a wind turbine. Tidal energy is considered renewable because the tides move on a predictable daily schedule depending only on the orbits of Earth, Moon and Sun and are essentially inexhaustible. Though tidal energy is carbon free, it is not environmentally safe. Concerns over the health of shoreline and aquatic ecosystems mar this otherwise clean source of energy. Older tidal barrage technology can devastate fish population. In the past, large scale barrage systems dominate the tidal power scene. But because of increasing evident unfavorable environmental and economic drawbacks with this technology, research into the field of tidal power shifted from barrage system to tidal current turbines in the last few decades. This new technology leaves a smaller environmental footprint than tidal barrages, as turbines are placed in off seashore currents, avoiding the need to construct dams to capture the tides along ecological fairage coastlines. The gravitational force of attraction of the moon causes the ocean water bulge on the sides of the earth that faces the moon. The centrifugal force produces the same effect, but in the opposite side of the earth. On these two sides, it can observe the minimum amplitude of the tides, high tides, and on the midways of it occur the minimum amplitudes of the tides, also called low tides. As the earth rotates, these two bulges travel at the same rate as the earth's rotation. The moon rotates around the earth with respect to the sun, approximately 29.5 days, lunar moon, in the same direction that the earth rotates every 24 hours. The rotation of the earth with respect to the moon is approximately 24.48 hours, that is 24 hours and 50 minutes, and is called lunar day. This is the reason why the tides advance approximately 50 minutes each day. In a simple term, a barrage is built at the entrance of a gulf and the water levels vary both sides of the small dam. Passages are made inside the dam and water flows through these passages and turbine rotate due to this flow of water under head of water. Thus, electricity is created by using the turbines. Now, let us discuss about geothermal energy. You all have heard about geothermal energy. Now, we will discuss in detail. Geothermal energy is an inexhaustible source of energy and is available from Earth's crust. It is that renewable energy source which does not need any fuel to generate electricity, and emission connected with geothermal energy are very less and negligible compared to emission that results from fossil fuels burning. Geothermal energy is gaining importance as alternative sources of energy. Geothermal energy based power production over the world has gone up from 5,800 megawatt to 8,400 megawatt from 98 to 2010. It is observed that most of the places in India do not have a sufficient energy sources and hence to be dependent on the other parts of the country. So, the geothermal energy may be one of the viable solutions for these state and provinces. Geothermal energy is obtained all over the planet. However, the earth takes several years to generate this energy by decaying the minerals and forests. Geothermal energy resources. Geothermal energy is the energy that comes from deeper part of the earth's inside. It is due to the phenomena of slow decaying of radioactive particles present in the core of the earth. This leads to the formation of geothermal energy. Earth has 4 parts or layers. Let's discuss in detail. Inner core, it is composed of solid iron. It is around 1500 miles in a diameter. The outer core is composed of hot molten rock called magma. It is about 1500 miles thick. Mantle of magma and rocks which surrounds the outer core. It is about 1800 miles thick. The crust of the solid rocks from the continents and ocean floors. It is 15 to 35 miles thick in the continent part and 3 to 5 miles thick in the parts of the ocean. Now, important applications of geothermal energy. Geothermal energy is used for generation of electricity. Geothermal power plants are established near the geothermal reserves. From these reserves, steam arises which is directly used to rotate the turbine connected to an electrical generator, and thus electricity is produced. Geothermal energy is used in agriculture and farming, especially in cold countries where it is used for heating greenhouses, for heating water requiring for irrigation. It is important in various industries like gold mining, food dehydration and milk pasteurization. It is also used for heating buildings by using direct heating systems. Space heating and cooling. Second, generation of electrical power. Third, it can also be used in industrial processes heat. It can have other applications which include desalination of water, heavy water production, extraction of minerals from geothermal fluids, timber, seasoning, etc. However, the geothermal energy is presently utilized mainly for power generation and space heating purposes only. Geothermal energy use, more than 20 countries are utilizing this natural energy today. Amongst them, the USA is the biggest generator of geothermal energy in the whole world with the most extensively geothermal field. We can divide the use of geothermal energy into three categories. Direct uses of geothermal energy. It is the most common applications of geothermal energy in which low temperature geothermal resources are used, such as natural hot springs, therapeutical spas, aquaculture ponds and greenhouses. Also, it is an excellent source for cooking, milk pasteurization, drying fruits, vegetables and timber in the industries. Second, electric power generations. One of the most popular use of geothermal energy is to produce electricity. Since most of the geothermal energy from the earth's crust can bubble out as a magma steam or water, it's extracted by building thermal plants. This renewable source of energy generates through three different techniques, that is dry stream, binary and flash. After digging wells 1 or 2 miles deep into the ground, power produces from geothermal energy by entering the hot water and steam into it. This generated energy runs turbine connected to the electricity generators. The USA, Indonesia and Philippines are successfully using this energy. Apart from these countries, Kenya and Turkey are also efficiently establishing geothermal energy plants. Geothermal energy extracted from earth through dry steam technique. Steam from hot water is converted into power using the turbine and generator, then injected back into the earth's surface after cooling. Geothermal heat pumps. Geothermal heat pumps or geothermal functions by using geothermal energy found within 300 meters of earth's surface which has a moderate temperature. The GHPs help draws warm air from a building to cool them down during summer. On the contrary, it warms the building in the winter season. Now let's discuss a bit about fuel cell. A fuel cell is a device that uses hydrogen and oxygen to create electricity by an electrochemical processes. A single fuel cell consists of an electrolyte sandwiched between two thin electrodes. Hydrogen or a hydrogen rich fuel is fed to an anode where a catalyst separates hydrogen negatively charged electrons from positively charged ions. At a cathode, oxygen combines with electrodes and in some cases with species such as protons and water, resulting into water and hydroxide ions. The electrons from the anode side of the cell cannot pass through the membrane to a positively charged cathode. The amount of power produced by a fuel cell depends upon several factors such as fuel cell type, cell size, temperature at which it operates and a pressure at which the gases are supplied to the cell. Fuel cells are classified primarily by the kind of electrolyte they employ. This determines the kind of chemical reaction that takes place in the cell. The kind of catalyst required, the temperature range in which the cell operates, the fuel required and other factors. There are several types of fuel cells currently under development, each with its own advantages, limitations and potential applications. Basic energy conversion of a fuel cell can be described as chemical energy of the fuel is equal to electrical energy plus heat energy. Hydrogen. Hydrogen is the simplest and most abundant element on the earth. Hydrogen combines readily with other chemical elements and it is always found as a part of another substance such as water, hydrocarbons or alcohols. Hydrogen is a clean alternative to methane, also known as natural gas. It is the most abundant chemical element, estimated to contribute 75% of the mass of the universe. The existence of hydrogen as a chemical substance in the nature with the molecular formula of H2 is not readily available and it is often in the form of compounds called hydrides with a negative or anionic character denoted as H-, as well as other technologies include, for example, electrolysis and thermolysis. Hydrogen is abundant and is the most available renewable energy. It is considered as the cleanest energy source. Hydrogen is also deemed to be the suitable solution for environmental problems if it is produced from renewable sources. The advantages of hydrogen are zero emission of the greenhouse gases. Now, let's summarize today's video session. Today, you have learnt solar energy, wind energy, biomass, tidal energy, geothermal energy, fuel cell and hydrogen energy. So, I suppose you must have had a good learning experiences watching this video. So, keep watching and enjoy learning. Thank you.